Hey everybody. So in this lesson, we're going to be talking about the standard normal distribution. But before we get into that, it'll be helpful if we first review what we learned in lesson 12 about the difference between a discrete random variable and a continuous random variable. So I'm going to go back to the worksheet from week 4, where we looked at only discrete random variables. Well, we looked at examples of discrete random variables, but we did first talk about the difference between a discrete random variable and a continuous random variable. And here is that difference here. Discrete random variables are things that can only take a finite number of values, certain particular values. You can usually count them, like those red dots on that number line. It can either be 1 or 0, 1, 2, 3, 4, 5, so on and so forth. It can't be like 5.5. But a continuous random variable, I don't like the way this looks, but a continuous random variable, on the other hand, can take on a range of values. So it could be anything, I'm shading this number line here. It can be anything between 0, 1, 2, 3, 4, 5. It could be 3.5. Notice that I'm not just shading the dots this time. I'm shading the entire number line. It can take on any of those values. Now, last week when we talked about a discrete random variable, we talked about what the probability distribution for a discrete random variable looks like. So here's an example where we did that. This is from the summary video from week 4, where there was a survey given to high school students about they had to give a score of 1, 2, 3, 4, or 5 on how likely they would be to attend RCC. And a 3 meant that they had no opinion on it. A 5 meant they were very likely, so on and so forth. We formed this probability distribution for that discrete random variable. What we're going to talk about this week is forming probability distributions. So things like this are probability distribution for a continuous random variable. But that's going to be a little bit different, and let's go look and see how that's going to be different. So in this box here, I'm just going to copy over that same example that we had from that summary video. I'm going to talk about what the discrete random variable was, and I'm also going to copy over the probability distribution for it. And then we're going to look at an example with a continuous random variable. Okay, so far I have written down what my discrete random variable is. It was the X value, the score on a scale of 1 to 5 of how likely a high school student was to attend RCC after graduation. So that student could have responded with a score of 1, 2, 3, 4, or 5. And we saw that there was what we calculated last week was there was a 16% chance they would say a 1. There was a 22% chance their score would be 2. There was a 28% chance that their score would be 3. A 20% chance that their score would be 4, and then a 14% chance that they would give us a score of 5. And then we did a bunch of examples, and we looked at what's the probability that their score would be less than 4, and we did different problems like that. But all that is just for a discrete random variable. Keep in mind here that these 5 numbers are the only options that the students could have given us for the survey. But on the other hand, let's say that we considered the continuous random variable of perhaps how many hours an employee at RCC is spending a day making calls to these high school students to try and encourage them to come to RCC. So I'm shifting gears here. We just talked about the discrete random variable with the certain number of scores that it could take. Let's now consider a continuous random variable. So this is the main reason why, we went back and we reviewed lesson 12, so we know the difference between a discrete random variable and a continuous random variable. Let's give an example of a continuous random variable now. So I've given an example of a continuous random variable where X is now the number of hours that is spent a day that an employee makes making phone calls to high school students to try and get them to come to RCC. If you're writing along, taking notes with me, I would not write what I'm about to write right now, but let's try to make this a similar probability distribution over there. Okay, so one, I have to think about what my values of X are. And again, I would not be writing this down if I were you, but just watch how this does not work. Well, they could make 0. They could spend 0 hours a day making calls. They could spend 1 hour a day making calls. They could spend 2 hours a day, 3 hours a day. But then they could also spend only half an hour a day making calls. Or maybe they only spent 0.8 hours a day. Or maybe they spent 1.23. Or maybe they spent 1.0009. So I hope that you see how silly it is to sit here and try to do what I'm doing in this green box, because there are infinitely many values that this continuous variable could take on. The whole problem that we're running into right here with trying to make the x values for this probability distribution is the difference between a discrete random variable and a continuous random variable. So now that we have that established, let's talk about what the probability distribution, what this would look like on this side. Well, we've already seen that trying to make a table for it will not work because there are infinitely many values that x could take on. So instead of trying to list them all, we are going to write them in an interval. What we do know is that x could take on any number of values between 0 and 24 because there are 24 hours in a day. But it could be 12, it could be 6, it could be 18, it could be any of these values. It can also be maybe something in there, something in between. I'm not saying that it has to be any of the values that it necessarily lands on, that they're labeled, but it could be. So this is why I'm really shading this line here to show that x could take on any value on that interval between 0 and 24. And I should have left some space down here for me to label this, but I'll just put here number of hours. So let's say that this isn't a great example. I am just making this up as I go. But let's say, and I know this isn't actually going to work out. Well, it's not realistic. I'll put it like that. But let's say that the average person spends maybe 6 hours a day making calls during their regular 8-hour workday. Let's say this. So that's why I said it's kind of not realistic, because most people wouldn't spend 6 hours a day on the phone. I guess depending on what job you have, you could. But I digress. But let's say that most people are spending around 6 hours a day making calls. Most people. So then fewer people would be spending maybe around 4 hours a day making calls, and maybe around 7 hours a day making calls. Fewer people. If most people are doing 6, there'd be less people doing that. And then as we got further and further away from what the most people are doing, what's happening in the middle of this curve, then I'm kind of getting this shape that looks like this. This kind of bell-shaped curve that we're getting in here. And we'll talk more about that bell shape in a little bit. But the main point I want to make right now is that what this probability is, what this table tells us on the discrete random variable side, is the same kind of idea that this curve tells us on the continuous random variable side. Here, on the left side, I can look and say, well, hey, if they're scoring a 3, there's about a 28% chance that they're going to give us a score of 3. But on the other side, let's say I go and I look at 9 and I say, well, what's the probability that someone is spending about 9 hours a day making calls? Those are the kind of questions that we're going to be answering in this lesson using curves that look like this for continuous random variables. And the answer is going to have to do with the area that is under this curve. The area that is under that curve, depending on what value it is that we're interested in. So remember, before we did questions like, oh, well, what's the probability that the student scored less than 4? We would add up all of these to find the probability that the student scored less than 4. If I wanted to know, on the other hand, now in this lesson, the probability that someone spends 9 hours a day or less, then I would need to find this area off to the left. So that's just a kind of general overarching overview of what we will be looking at in this lesson and tying it into what we learned last week.